Upgrading your RV to a lithium battery system might sound intimidating at first, but what if I told you this single upgrade could completely transform the way you travel, camp, and live on the road? Imagine running your air conditioner longer, charging your devices faster, cutting generator noise, and finally enjoying quiet, uninterrupted power wherever you park. No more worrying about draining your batteries overnight. No more babysitting charge levels. Just clean, reliable energy that works when you need it most. If you've ever felt limited by your old lead-acid setup, short run times, slow charging, constant maintenance, then this step-by-step DY lithium battery upgrade could be the most rewarding project you ever take on for your RV. And the best part, you don't need to be an electrical engineer to do it. With patience, planning, and the right guidance, you can safely complete this upgrade yourself and save thousands of dollars in the process. Before we dive in, if you enjoy practical RV upgrades, off-grid power freedom, and step-by-step DIY guides that actually make complex projects feel doable, make sure you subscribe and stick around, because this channel is all about helping you travel smarter, camp longer, and build the RV setup you've always wanted. The first thing to understand is why lithium batteries are such a game changer compared to traditional lead-acid or AGM batteries. Lead-acid batteries typically give you only about 50% of their rated capacity if you want them to last. Drain them lower too often, and their lifespan drops quickly. Lithium batteries, on the other hand, let you use 80 to 100% of their capacity safely. That means a single 100A lithium battery can deliver nearly double the usable power of a 100 lead-acid battery. They're also dramatically lighter. Weight matters in an RV, not just for fuel economy, but for cargo capacity and suspension strain. Lithium batteries can weigh half as much as equivalent lead-acid setups. Charging speed is another huge advantage. Lithium batteries accept current much faster, meaning your solar alternator or short charger can refill them in a fraction of the time. And lifespan. This is where lithium really pulls ahead. A quality lithium iron phosphate battery can last 3,000 to 5,000 charge cycles or more. That's often 8 to 10 years of real-world RV use, compared to 2 to 4 years for many lead-acid banks. Now let's move into the actual upgrade process. Before buying anything, you need to calculate your power needs. This step determines battery size, inverter capacity, and wiring requirements. Start by listing everything you plan to run: lights, fans, water pump, fridge, laptops, CPAP machines, microwave, coffee maker, air conditioner if applicable. Look at wattage labels or manuals. Multiply watts by hours used per day to estimate daily consumption. For example, if your fridge uses 60 watts and runs 10 hours, that's 600 watt-hours. Add everything together to get your daily total. Many RVers land between 1,000 and 3,000 watt-hours per day depending on lifestyle. Once you know this number, you can size your battery bank. Lithium batteries are measured in amp-hours, but converting to watt-hours helps amp-hours tot voltage watt-hours. A 12V under a lithium battery equals about 200 watt-hours. If you use 2 400 watt-hours daily, 2 batteries would cover 1 day comfortably. Next comes choosing battery type. For most RV dyers, lithium iron phosphate LiFePO4 is the safest and most stable chemistry. It has excellent thermal stability, long lifespan, and built-in battery management systems that protect against overcharge, over-discharge, and short circuits. Now you'll want to inspect your existing battery compartment. Lithium batteries can be installed in the same space as lead-acid, but there are considerations. They don't require venting like lead-acid, since they don't off-gas under normal operation. However, they do need protection from extreme cold. Charging lithium below freezing can damage cells unless the battery has a built-in heater or low-temp cutoff. If your batteries sit in an exterior compartment and you camp in winter, insulation or heating pads may be necessary. With planning done, it's time to remove the old system. Disconnect shore power first, then switch off your inverter and solar. Remove the negative cable before the positive to reduce short circuit risk. Lead-acid batteries are heavy, so lift carefully and use gloves. Acid residue can be present even on sealed units. Clean the battery tray thoroughly. Neutralize any corrosion with baking soda solution, then dry the area. A clean base prevents wiring contamination and improves installation safety. Now comes one of the most important upgrade steps: evaluating your charging systems. Lithium batteries require compatible charging profiles. Many modern converters and solar charge controllers have lithium settings, but older units may overcharge or undercharge lithium banks. Your converter charger should output around 2 to 6 volts for bulk absorption and then stop or float lightly. If your existing converter is outdated, upgrading to a lithium-compatible model ensures proper charging and full capacity usage. Solar controllers must also be lithium-compatible. MPPT controllers are ideal because they harvest more energy from panels and charge lithium efficiently. If you charge from your alternator while driving, you may need a DC-DC charger. Lithium batteries draw high current which can strain or overheat alternators if connected directly. A DC-DC charger regulates flow and protects both systems. With charging sorted, you can begin battery installation. Place lithium batteries securely in the compartment. Even though they're lighter, they must be strapped or bracketed to prevent movement while driving. Next comes wiring configuration. If you're installing multiple 12V batteries, you'll wire them in parallel to keep voltage at 12V while increasing capacity. Connect positive to positive, negative to negative using equal length cables for balanced charging. Use thick, high-quality cables, typically 2-putter low or 4-putter gauge depending on inverter size. Lithium systems can deliver very high current, so undersized cables create heat and voltage drop. Install a main fuse close to the battery positive terminal. This protects your RV from catastrophic shorts. Class T or AL fuses are commonly used in lithium setups. A battery disconnect switch is also essential. It allows you to shut off power instantly during maintenance or emergencies. If you're adding an inverter upgrade alongside lithium, mount it as close to the batteries as practical to minimize cable loss. Ensure adequate ventilation. High loads generate heat. Now it's time to connect the system. Always connect positive cables first, then negative last. This reduces accidental short risk. Tighten terminals firmly but avoid over-tightening, which can damage posts. Once connected, power up gradually. Turn on the battery disconnect, then converter, then solar, then inverter. Watch for error codes or abnormal readings. At this stage, a battery monitor becomes incredibly valuable. Unlike basic voltage meters, lithium batteries maintain steady voltage until nearly empty, making voltage alone misleading. A shunt-based monitor tracks real amp usage, state of charge, and time remaining. This single device gives you precision awareness of your off-grid power, something lead-acid users often struggle with. Now let's talk safety and best practices. Lithium batteries are very safe when properly installed, but system protection matters. Always fuse positive lines, use quality lugs and heat shrink, secure cables to prevent vibration wear. Temperature monitoring is also wise. While LiFeO4 is stable, electronics last longer when kept within recommended ranges. One major benefit you'll notice immediately is voltage stability. Appliances run more efficiently because lithium holds near constant voltage through most of its discharge cycle. Lights don't dim, fans don't slow, inverters don't alarm prematurely. Charging speed will likely surprise you too. Solar recharge happens faster. Generator runtime drops significantly. Even short drives can restore large portions of capacity. Maintenance is another area where lithium shines. No watering, no equalization charges, no corrosion from off-gassing. Install it properly, and it largely becomes a set-and-forget system. Cost is often the biggest hesitation. Lithium has higher upfront pricing, but when you factor lifespan, usable capacity, generator savings, and reduced replacements, many RVers find it cheaper long-term. And then there's the lifestyle upgrade, something harder to quantify but immediately felt. Boondocking becomes quieter, longer, less restrictive. You stop planning days around power anxiety. Morning coffee doesn't feel like a battery sacrifice. CPAP users sleep easier knowing power will last the night. Content creators can edit charge drones and run gear off-grid. Families can run lights and movies without constant monitoring. It transforms the RV from a power-limited vehicle into a self-contained energy system. Of course, no upgrade is complete without testing. After installation, run a full discharge and recharge cycle while monitoring performance. Verify solar input, converter charging, inverter loads, and alternator contribution if applicable. Watch cable temps under heavy loads. Warm is normal, hot indicates undersized wiring. Check that fuses remain cool and connections tight after the first few trips. Over time, you'll develop an intuitive feel for your new system, how long it lasts, how fast it charges, and how much freedom it provides. Many RVers who complete this upgrade say the same thing: they wish they had done it sooner. Because once lithium is installed, it doesn't just improve power, It changes how you travel. You stay off-grid longer. You choose campsites for beauty, not hookups. You hear nature instead of generators. You rely on sunlight instead of fuel. And perhaps most importantly, you gain confidence in your rig's ability to support your lifestyle wherever the road leads. If this guide helped demystify the process and made a lithium upgrade feel more achievable, don't forget to subscribe for more deep dive RV tutorials, off-grid system builds, and step-by-step upgrades designed to save you money while expanding your freedom on the road. Because the goal isn't just better batteries, it's better travel, better comfort, and the ability to go farther, stay longer, and explore without limits. Your RV is more than a vehicle. With the right power system, it becomes a home that follows you anywhere.